Okay, it's Roger once again, Mudfossil University. Today trying to do a little research, trying to resolve some of the problems we're having here on the planet. And all around the globe, they're getting hot weather, floods, all kinds of problems. And the reason is we're spinning through a dense region in space. Now, if you don't want to save the Earth, this is not your place. We're spinning through this thing in the atmosphere that is extremely dense, and it is heating our atmosphere because we are nothing more than a motor. And NASA released these flares. They use some different chemistry in there, barium and strontium and metaluminals and things like that, to show up what is in the regions of the atmosphere as we spin through it. What is causing this? Now, you can see, I'll try to explain it the best I can. Now, this is the deal. Watch. You see what they did? They dropped these. Whoops! I keep doing this. I hate that when they have that thing come up. They dropped these flares as they go. Two rockets, one here and one here, and then you can see it drift away as the planet's spinning this way. You'll see it come this way. Now, what are these different colors? You see this region right here? See that? That's an Aurora Borealis line. That's another Aurora Borealis. That is another zone in our atmosphere. They're layers of our atmosphere. They're checking these to see what is the intensity of the electrical activity out there. And I think they understand there's a real problem in these layers getting too much electrical activity, because there's a new phenomenon called Steves. And these areas up here are shooting out rays because they're overcharged. This is something new. They just figured this out in the last year or so, that the upper atmosphere is becoming overcharged. Brand new phenomenon. We're going to go into that, Steves. Alright, now, here is the Earth. You see these lines I put down here, plus, minus, plus, minus? Those are the actual lines in the Earth. They're called ocean magnetic stripes. We'll look at it in a minute. Now, as you go up, it's 80 degrees Fahrenheit down here. It goes out to minus 60, drops way off, down to minus 120. Then it goes up to 2,700, then to 58,000. The 58,000 way out here is because we're scrubbing through the particles that are crushing into our atmosphere as we spin through it, because we are nothing more than a generator. In a generator, you have lines of plus, minus, plus, minus, plus, minus. It spins in a magnetic field, which is made by magnets. When you spin, it has to force these lines, which do not want to be forced, as they have to be forced through those magnetic particles. And they induce currents into these magnetic lines. And as they induce the particles into the lines, it creates an alignment of a north and a south pole according to the spin of the Earth. Now, these are aligned on the spin of the Earth. All right? These are actual lines in the Earth. So there will be a problem if this Earth, instead of hitting forward like this, starts hitting forward like this. It might flip. It might flip. Because as it circles our entire galaxy, at some point it's this way, and way over here it's this way. So if the center hits this way, or the center hits this way, at some point things could flip. It could be the whole solar system that flips. I have no clue. It depends on how we are oriented in this soup. And that's what it is. It's an electron soup. We're crushing through it. I'm going to show you how this spins through that. The particles out here are being forced into the particles in here, and at 58,000 degrees out here. We could test all this, and I think that's what they're doing right now with this right here. I hope that's what they're doing, because there's something going on in these field lines. We're going to go a little deeper right now. You see this right here? Comment. There couldn't be a more important time to study our changing atmosphere. New celestial phenomena, Steves. These are what we're going to talk about in a minute. Closely correlated with violent disturbances in Earth's magnetic system. Says study. Our changing atmosphere, stunning iridescent cloud over Mexico, complex solar halo over Russia, triple rainbow over Norway, changing atmosphere, red sprites, and a blue jet seen above Europe's stormy skies. We got issues. Here's another one. Forget global warming. Worry about the magnetosphere. Earth's magnetic field is collapsing and could affect the climate and wipe out the power grids. The magnetosphere and the magnetic poles are moving so fast they just had to recalibrate the global positioning system, otherwise you wouldn't know where you were going. It's moving way ahead of schedule. Now, the polar north is what they're focusing on. Now, polar north is a function of the spinning particles of the spinning Earth and its alignment to the particles that are coming into it, and how hard those are pushing at our poles. And they appear to be pushing hard right now because they seem to have pushed the pole. And I will show you why I say this. Now, I just want you to know, Wile E. Coyote, you got nothing on me. I've been setting up boards trying to figure this out for a while now. But here's the deal. Alright, you see up there to the left, you got your sun over there on the left. Alright, it's shooting out all of these particles at the Earth. And as we plow through the atmosphere and our Earth spins, it's spinning this way. And as it comes at 10 o'clock and 10 p.m., you get these high crushing effects from the sun because, or from the particles that are hitting towards our Earth. And then at 4 a.m. or 4 p.m. you get a low pressure because it's on the sides and it's sweeping by those areas, but it's crushing into the 10 a.m. and 10 p.m. regions. So what does that tell you? That tells you that we are being forced into something that's crushing it and making these daily perturbations. They've been going on. They've recorded them since 1600s. They just couldn't understand why. The reason is because we're being crushed into oncoming particles of ether. It's like we're pushing against something's friction. Now, the other thing that they never really could take into account and understand is that the sun itself is only 6,000 degrees on its surface, but out here at the coronal edge, where it rubs against the atmosphere, it's millions of degrees. It's obviously rubbing at that surface. Why would it be less temperature at the surface and millions of it's obviously rubbing with friction. The other thing that's obviously happening is Venus on its axis spins in the reverse to everything else. It's doing the left-hand rule. It has no magnetic field to speak of because they don't propagate a magnetic field when they spin in reverse. And in addition to that, it is rubbing backwards into the ether, creating 800, 900 degree temperatures on the surface instead of 80 degrees like we have here. And it is virtually in the same, solar arena that we are. Not much difference, not much bigger or smaller. It's not all that distance further than we are. It's our sister planet. It should be similar to us, and it's not. It's totally different. And it's because of what we're rubbing through. It's as simple as that. So, if we don't understand this, and all we decide is to just cut off the carbon dioxide, that is not the answer. The carbon dioxide is not the answer. It's absolutely not the answer. I don't care what anybody says. You speak against it, they shut you down. Oh, I can't talk because he's saying something that's not right. Well, who says it's not right? That's the problem. Listen, it's not obviously not right if you don't listen, but there's so much happening that you cannot discount it. Let's take a look at the sprites. Alright, these are some phenomena called sprites. They're shooting up from the Earth straight up into the air. And they're discharges of additional electrons into the air. Now, here's some other ones. Now, they come up from the Earth and they smash into these layers up here and they drop the stuff back down. This is not discharging down. This is coming back because the electrons coming up were so intense that they filled this area with too many electrons. They have to come back down to try to get back down to the Earth. They are just flooded up into there. Now what do we got here? Here's some sprites. Here's some, look, see this? That came out of here, up, smashed into here. You see it going up. You see these going up, 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 up. That's coming from the Earth. And now it has so much energy up here, it has to come out. It can't stay there too much. And it comes back down to try to find the Earth. That's what happens with these sprites. And they're just starting to understand. I hope they are, because they're a sign of what's going on. You see? They say they come up from here and shoot down. No. This is the problem. I can't see how they can miss this. They're coming up and then coming back down. Now the ionosphere is the place that we're really looking at, because ionosphere, ions means they're particles that are not, they're charged particles. Now they say they're positively charged particles. That's not correct. They're negatively charged particles up there primarily. They strip them off. There's particles that are being stripped, and there ends up with protons, yes, but those protons are going to attach to electrons pretty quick. It's the excess of electrons that they're dealing with out there, not proton ionization. This is important, so I'm going to read this. It says, when you gaze out into the space, it may seem like you're looking into a dark void, although it looks like emptiness. Above the Earth, the atmosphere is actually made of layers with different atoms, molecules, types of energy. If we travel about 30 miles from Earth's surface up to the edge of space at about 600 miles from the surface, we will encounter a layer of the atmosphere called the ionosphere. Ionosphere. That's where you have ions. Those are charged particles. Now, in the ionosphere, radiation from the sun, so the sun is shooting down its radiation from the sun, is so powerful that it ionizes or breaks electrons free from fixed atoms present in the atmosphere due to fluxes in solar radiation. Pulses, extreme storms, solar flares, shooting out particles, okay? So due to fluxes in solar radiation, temperatures in the ionosphere vary from minus 99 degrees to 440 degrees. I'm using Fahrenheit. Minus 99 to 440, that's 550 degree difference. Now, how is the ionosphere formed? Right? It's electronic particles. It's particles that have been smashed by other particles and joined by other particles. So it says, how do we get all these charged particles in the ionosphere? Atoms in oxygen and nitrogen are main targets of ionization. Now they call it ionization because, yes, absolutely they're going to ionize, but the bulk of the things that are hitting us are already just photons and negative particles. They're just electrons. Those are the things that are floating through space that we can't see. We don't think are there. They're dark energy, dark matter. They're just there. They're trying to get to us. And then they become mixed up in our ionosphere. So a very high light energy from the sun excites atoms in these atoms during a process called photoionization. Photons coming, ionizing, but they're also negative particles. The atoms in turn release negatively charged particles. Yes. But they're already there. They're mostly electrons coming anyway. So the other ones release them when they get cracked. I agree with that. The atoms gain a positive charge as they release the electrons, and more chemical reactions happen. For an instant, but they're just going to jump right back into adding more electrons, because electrons flood any positive cores. When these chemical actions occur, some energy from the excited electrons is released as light. Absolutely, that's the glowing corpuscles. I can't explain that, but they do. When you crush them together, they emit a glow. That's just a fact. It's energy. Creating a phenomena called air glow. They're bouncing back and forth. They're just glowing in the air. The air glow is diffused light that allows us to see objects in the dark, even on extremely dark nights. Okay? So now we come down to the layers of our atmosphere. The ionosphere isn't just a uniform mix of ions. As it has specific layers. In this one layer alone, it has specific layers that have different compositions. The D region is the lowest region of the ionosphere, closest to the Earth, extending between 40 and 55 miles above the surface. The D region doesn't stay electrically charged at night like the others do. Why is that? Why doesn't it stay electrically charged at night? It's not being flooded with electrons. I mean, how hard is that to understand? Without the sun's ionizing radiation, without the sun's electrons, the oxygen and nitrogen molecules combine to become neutral, and this layer no longer deflects radio waves back to Earth. Okay, before, when it's being bombarded with electrons, it's so negative there that you can't push anything through it. The negatives just get away and they bounce back to Earth. All right? At night, it won't do that because there's no more electrons up there, because there's no more flood from the sun. Right? Then it goes, have you ever thought about calling someone across the ocean? You might have ever done this yourself, but before 1902, communications across us was impossible because they didn't realize they could bounce it off of here. Well, to make a long story short, well, I'll read the whole thing because it goes into that. You can do this at night, but you have to use the upper region. Right? So, they say you can transatlantic, and then they figured out how to do this. This was the first step in global radio communication we know today, and wouldn't have been possible without the next layer of the ionosphere, the E region. So you got this region goes away at night, then you got the E region. Unlike the D region, the E region remains charged at night. It's the higher up. Although some of the ionization does decrease, yes, but it's higher up enough so that it's pulling down from what is being interacted. It's still enough to continue to bounce radio waves from long-distance communications. The last layer of the troposphere is, the ionosphere, is the F region. The F region sits about 100 miles from the surface and has the greatest concentration because it's getting the most electrons compared to the other layers. This layer maintains a mostly steady state of ions even at night. The F region can be divided into two subregions. F1 closer to the Earth, F2 which is farther away from, has the greatest concentration of ions. Farther away, the greatest concentration. Obviously, it's being bombarded by those particles that are flowing to Earth that are the dark matter and dark energy. It just never, how do they think they get here? Anyway, it goes on to these different distances and what they do and how they can bounce the light off and so forth. And then you have to become a member if you want to learn any more. I learned enough. All right, this is another issue this started me looking into this because this is a new phenomenon that they have never seen before, and all of a sudden it's showing up. And this is nothing more than we're being overcharged on the Earth, and it's shooting out these blasts of pure electrons at 3,000 degrees, which is, there's just no other way to understand this other than to what's going on. NASA says, oh, let's keep looking at this and try to figure it out. Well, there's nothing here to figure out. Atmospheric optical phenomena appears as a blue-green light ribbon in the sky, formerly discovered in late 2016 by just some guy looking in the sky, an Auroral watcher from Alberta, Canada. According to analysis of satellite data from European Space Agency SWARM mission, Steve is caused by a 25-kilometer, 16-mile wide ribbon of hot plasma at an altitude of 280 miles out in the ionosphere with a temperature of 3,000 degrees centigrade, which is exactly the temperature of raw electrons, flowing at a speed of 3.7 miles a second compared to 10 miles a second outside the ribbon. I mean, look at the difference. It's discharging. And the other part is just sitting out there saying, all right, we're just laying around. And this thing's going, let's get out of here, man. We got too much. The phenomenon is not rare, but nobody had looked into it in detail before. On August 2018, researchers determined that the phenomenon of sky glow is not associated to particle precipitation, and as a result could be generated in the ionosphere. Obviously could be generated in the ionosphere. It's all electron particles. It's not particle precipitation. Electrons or ions. It is electrons being discharged. I don't know how they say it's not precipitation. It is discharged electrons. They're shooting out. And they go on a certain angle, and I'm sure it has something to do with the way the Earth is spinning. It's got called a proton arc. When physics professor so-and-so at the University of Calgary saw the pictures, he suspected it was not the case because the proton auroras are not visible. As he correlated the time and location of the phenomena was very clearly distinguished. They can see it. Now they say it's a phenomenon. Well, we don't fully understand it. Well, there's nothing more than that. How could you not understand it? How can you not see that and understand it? It's discharging. There's tests we can do right now that I hope they're doing, that are going to test, I hope they're testing, to see is the magnetosphere increasing in temperature? What is going on? How much charge is there associated to our ionosphere now? What's the saturation now? It obviously is discharging back into space. It's saying I'm charging up too much. I got too much here. I got too much here. You got to get some away, and it goes out into space, and I can't for the life of me figure out where it's going to, because space is not an attractive negative particle puller. So where is it going? That's my question. It's drifting off into space, being sucked away from us because we just have too much. But where the hell is it going? There's got to be somewhere where there's a charge, a positive mass that's accepting these electrons. Because they're not going to drift off in a blast like that unless they got a target. So there's a lot to understand here. Alright, I'll leave it on these Steves. It says this bright purple ribbon named Steve. Entirely new celestial phenomena. Recently discovered. Alright, and it is because we are overheating, because we are rubbing through space, and the particles in space are heating up us just like they heat up a motor and a generator when you try to force it through electrons. It does work, but it creates heat.